a question. I'm kidding. I appreciate you coming tonight. If not, our success criteria for this session is that when you leave here, you understand a little bit about what Adaptiva OneSite is, what it does, how it does it, and some of the benefits that actual clients are getting from using it. So it's interactive. We'll let you ask some questions. We even allowed Paul, our competitor, to come in here from 1E. So I appreciate it, Paul. So we've got by way of introduction, I'm Todd Floyd. I run sales and operations worldwide for Adaptiva, based in Seattle. With me today, we've got Deepak Kumar, who is founder and CTO. So the technical side, engineering and development, all the stuff that you're seeing today was created by Deepak and his team. Also presenting with us today will be Neil Saul from Cargill. Neil's been a customer for some time now. I actually brought a picture of Neil. He and I had a bet a long time ago, and he knows I don't gamble. My standard bet is 25 cents. And so we had a bet. He said, there's no way you're going to get it, and I got a picture of him last year here giving me that quarter. So Neil's going to talk about the bandwidth protocol management technology, one of our 4 key pillars from Adaptiva. Then Howard Bliss from Barclays will talk about the infinite cache file system. Third on the line will be Jason Snook from Flexera Software. He'll talk about daisy chain peer-to-peer. And then James Bannon, who is an MVP for Config Manager and also a solutions architect at Diligent out of Australia, one of our premier partners who handles all ANZ Australia as well as Singapore. Okay, that's going to be the role today. If you've got any questions, let me know. Where's my presentation up here?
Do you have the chip on you? Do you have the chip?
It's on your laptop. So I've got 2 slides. What I was going to ask is, I know there were a bunch of parties last night. We actually had one. I left at 3 minutes to midnight because I knew it would happen. Who feels that they should have this on their chair today? Deepak? That's a pretty good one. We had a good time. So those of you who were there last night, it was pretty fun. So it should be, no, it's right up there on the very top, Deepak. MMS 2013. There you go. Oh. And in power, there you go. And the next slide, if you would, Deepak, thanks. Here are the reasons these are the 5 most prevalent reasons that people come to us in relation to Adaptiva OneSite. And I tend to ask them, you can pick one of them. Right? Servers are expensive, bandwidth sucks around the world, in the US, edge cases, oil rigs, ships, I don't care what it is. Content is huge. Not only the volume, the quantity of content, but the gigabytes of volume in these packages. OSD takes a fair bit of time. I've talked to several of you today. I said we started our Windows 7 project 4 years ago. Well, there's circumstances and all that, but really, why not just kill them and refresh, in your 3-year refresh cycle? There's a lot of different reasons. So OSD takes forever, and it depends on really what hat you wear. And then the other one is I talked to somebody who said our new design called for 3,000 distribution points. I said, dude, you are in the expletive, which I will not share here. But, you're going to spend all your time doing that. So I typically say pick one. And what's the usual answer? Can I pick all of them? I said, yeah, you can, but you really got to pick one. So what we typically tend to do is we want to focus on find a business problem. And you guys I'm from Seattle, so you guys is generic, I apologize. You all have the same business problems, large distributed environment. Pick a little problem in a small area or a huge problem globally and bring it to us, and you'll see some technologies as to how we go about solving that. So I get the fact that you all have kind of the same problem. You may have done better in certain areas, but give it time, and you'll have it all again. So next slide, and we'll talk about these are the key architectural differences of our technology and what exists in the world. I'm not here to talk about our competitor. I'm not here to talk about anybody else other than to give you what we believe that our customers, which you'll hear from several of them tonight, and a bunch of people who have come to us and said, we have an existing solution. We want to see what you've got. These are them. I'm going to have our clients go into each of them. The Adaptive Protocol Network Driver. This is where we take our legal name from. This is the technology that Deepak and the team, when they were at Microsoft, had the idea for, took it to Super Bill Gates, said, we should schematize intent. Here's how we're going to do it. Any of you who know or have met Bill, as we have, he's got a lot of expletives. He said, go do it. And 6 weeks later, Deepak and the team said, we can do it. Can't do it here. Left, started the company in 2004. We've been around a long time now. And that is what you will see today. Neil will go through that. The second one is infinite caching. We say you can get rid of all the distribution points, which means all of them. So where are you going to store the content? All right, so we will show you the infinite caching file system today, a virtual SAN created in every subnet. Okay? We'll physically show you software. The other thing is if you want to see physical software, you can come and see us at any time in the expo. Get your hands on it, show it to you, live production software. This is the only PowerPoint you're going to see, and I have 2 PowerPoints. Daisy chain, true peer-to-peer daisy chain for content distribution. Jason Snook at Flexera will show you that. And then the final pillar is OSD. When OSD takes forever, you're going to see that you have internal processes. We may be able to speed that up a little bit. Okay? So with that, I'm going to introduce Neil. And any of you want more PowerPoint? Excellent. Questions on any of that? I'm going to have Neil come up, and he's going to go through the adaptive protocol. Don, questions? So I'd suggest that you pay attention because I'll call on you a little bit. You set on your mic?
Yep, I think so. Can you hear me?
Mm-hmm.
Okay.
Do you want one of these that pins on?
No, mine's bigger.
Go ahead.
And after gambling last night, Deepak said I might have a shot at getting my quarter back. My family would appreciate that. All right. I'm going to talk to you a little bit about the adaptive protocol. It's one of the unique things that Aptiva has. And I work in Cargill, so we're a worldwide global corporation, privately held business, dealing with agricultural commodities and things like that. We have about a 70,000 unit installation base that's running SCCM and Adaptiva. We're in the process of bringing SCCM 2012 online. And one of the objectives that we had was around the global distribution is the ability to transmit all this content to all of our locations over the wide area network without impacting the business. Okay, that's a huge thing. And we're actually doing that today with a legacy management system. And their method for distribution is a little bit old. I'm old, so I actually kind of like this one. I'm familiar with it. It feels good. I have an Atari at home. It's all great. So, and it's the basic calendar style. You're all familiar with that. So that's where you sit there and you figure out what your network is. You carve out a percentage of the network bandwidth that you'd like to utilize for the transmission. And then you can even set periods of the time where you can say, well, I'm going to make this run 20% during lunch and 10% during the day. And between midnight and 2 o'clock, I'll open it up to 80% utilization. So you can manage the bandwidth of your networks, which is fine. It's worked. It's kind of said and true. There are some disadvantages that you kind of get inherently with that, is that you don't get the opportunity to utilize any unutilized network bandwidth. You don't get to utilize that if it's available. And let's see here. And then with that, so then if you're only using 20%, for example, you just set up 20%, you're going to be throttled to that 20% until the whole transfer is complete. So that means when you're doing software distribution and stuff and you want to get it out there, it's just going to take longer to get it out there, especially since you wouldn't exceed your cap. The next style of transmission thing is called like a transmission with congestion detection. So what it'll do is it'll sit there and send a few packets and monitor the transmission rates. And as soon as it starts to see that the transmission rates are starting to take longer, it'll start backing off because it's recognizing that it's seeing congestion. Okay? So these are the transmission protocols that we're familiar with. Now, what the adaptive protocol does is it takes a different spin on this to remediate some of these issues. And what it does is it actually goes and looks at the router on the edge, and it inspects the queue length that's on the router. And then based on that, it does an initial calculation on what the threshold of the queue length should be for that router to determine whether or not it's starting to become congested. Okay? Once that calculation is complete and it starts transferring the information, it's going to send one packet and then go and ask the question, what's the queue length now? Has it exceeded that threshold? If it has, it stops sending. Okay? If it hasn't exceeded the threshold, it'll send another packet. And then it just does this repetitively until the transmission is complete. So, and when it's doing the interrogation on the routers, you don't have to give it the SNMP passwords or anything like that. It's all information that's publicly available on the router. So you don't have to go and program all of that stuff. All right. And actually what we have here in the demonstration is we've actually got two systems set up in Adaptiva. They're both connected to separate segments and they're connected together with a 1700 Cisco series router that actually has a T1 connection on it. So this is not a simulation, it's an actual demonstration using physical hardware. So what I'd like to do is, for this, is actually bring up the receiver side program that is what it's going to be doing is leveraging the adaptive protocol to do a transfer of information from one site to the next. So I'm going to bring up the receiver, and I'm also going to bring up the sender. This is going to be the place where it's going to be sending from.
So a lot of you who have seen this or heard us talk about it said, well, how do I see it? This is a brand new capability. We've had a couple private sessions. This is the first time that this has been publicly visualized. So Neil is going to show you the actual transmission of the data and what happens to the adaptive protocol network driver when other content comes into the pipe.
Right. So just to start this, I'm going to start the receiver. So it's going to be ready to receive the transmission. And then over here, I'll start the sender. And you'll see that since there isn't a load on the wide area network now, it's utilizing the majority of the available bandwidth. Okay? Now, I didn't have to go and set percentages or anything like that. It's just taking what's currently available, not increasing latency. It's monitoring for jittering. It's doing all of that stuff in the background. It's part of the protocol. Now, when someone wants to actually start using this in production, we're going to just copy a file from one segment to the next to show we're going to be using the wide area network for other functions. So I'll start the copy. And you'll see as soon as the copy initiated, the protocol immediately backed off. And now what's consuming the bandwidth now is this actual transfer that's happening. Okay? Now I'll cancel this just to simulate that they're done doing whatever work that they were doing. And now that the cancellation is complete, it sees that the queues are slowing or going down. It's now below the threshold, and it starts taking over your available bandwidth again. So this is interesting stuff. This is stuff that I haven't seen before myself until I met Deepak and family, who take money from me. So, and then once again, we can show it again. You know, bring up the local. We can start the copy again. And quickly, it's very responsive, comes down, and relinquishes its consumption of the wide area network. So,
And we could do it over and over and over again. The reason that we came up with this, and I've talked to several of you this week, I forget who it was, but they said that they felt like they were in the penalty box or in a timeout because the network team didn't shut down their SCCM environment like a lot of do. They gave them 5% of the bandwidth. So it's like a little kid, not just shut it all down, 5%. And they felt like, I mean, I can't do anything with 5%. So what we tell people is you pay for how much of the pipe? You pay for 100% of it. Use the whole damn thing. Use 100%, not 80%. Right? I'm going to save this other 20 for what? Or I got a completely redundant WAN system that I never get to use. And this will help you, if you have some network folks that are maybe not as friendly or not as trusting, will help you to display to them, here's what's actually happening. Test it, test it, test it, and then check for latency, check for jitter, and they will then really get, not that they're on your back, but I know they are. So they'll get off your back and they'll let you go about and do your day job more effectively. Okay. Real production software, you can see it just keeps going back and forth. You can see it down in wherever we are, 500 and some odd. So Neil, anything else that you want to run through?
well, one thing that was interesting for us, and we've had this experience in production ourselves, is the networking group known for adding networks and not so necessarily known for letting us know. The network comes up, we haven't configured our bandwidth throttling, we haven't gone through setting up the calendar for scheduling or things like that. So of course, our system will take advantage of what's available. It doesn't know that it's a wide area network because we haven't set it up to be identified as that, and we burn the wire. In this situation, new networks can come online and get configured by separate people, but yet it'll still respect the bandwidth characteristics and not burn the wire and impact the business. That's one of the huge things that I noticed because we get calls when stuff like this happens.
Awesome.
So.
Thanks. Question? Neil? Question here?
Yes.
If I want to get a critical application or less patched out, is there a way to easily disable this behavior and take up more bandwidth?
If the bandwidth is available, it'll utilize it. If you override, then you'll start impacting business functions. So, okay, that I don't know.
It's like 0 day?
Let's ask
Yeah,
Dad.
it's possible, of course. It's very straightforward. So there's a notion of content priorities within one site. And you can also select either generically or on a specific piece of content. There are settings that you can open up. You can say, hey, don't use the background transfer, use foreground transfer, and make it higher priority. Now, you're going to get not only TCP-like behaviors, it'll send in the foreground. You'll get one additional thing, which is, let's say an image is going at a low priority between a different set of machines. Your high priority content will make all that pause, even though it's on a different machine. Your high priority content will go through, and the lower priority content will then resume. And this is for the entire location. So if any machine on that location is currently downloading a low priority content, that's going to stop. So you're going to get, and I know what requirements are driving the question. You can get it done very quickly.
Other questions?
So what does this look like for your environment? So if there's like a site that has a lot of activity, not just SMB traffic, but other things going on, what's your,
That's a good question. So, there are a lot of indicators of congestion after the fact. Ping latency increases, jitter increases, a lot of indications after the fact. There is only one indication before the fact. Now, Neil explained in great detail how it works. But if you kind of enlarge that picture in your mind, we are looking at the queue on the interface that is connected with your WAN. Now, these packets haven't hit the WAN yet. They are going to hit. The only real indicator of congestion that is about to happen is the length of the data queue. When congestion happens, traffic backs up in that queue. You can look at it and instantly say whether it's going to get congested or not in future. Now, we are looking at the packets. They could be HTTP, TCP, whatever, right? It doesn't matter. They're just packets, and we are looking at the totality of all traffic. Okay? So it doesn't matter where it originated, which machine or which protocol. It's all IP traffic, well below TCP IP.
So the question is, maybe, do you need to change routers? Do you need to modify the routers?
Now we have layer 3 switches and VLANs, which route traffic, but the actual egress router is a Cisco router on top of that stack.
So could you hear that at all?
So it is difficult for me to disclose more, but that is a common scenario, and we handle it automatically. You're not going to have to tell us, hey, this is the router, this is the type, none of that. We will analyze each link, and there's actually an endless driver running under the cover. We know what kind of link it is. We analyze it first, and you saw that momentary pause when we started up. It takes a second or two. We figure it out, and we identify which routers we're going to monitor, and that's all automated. You don't have to worry about it. It will work on those scenarios as well.
It's a good question, though. It's common. I'd suggest you come over and talk to Deepak or the engineers in a little more private environment, and we'll talk through it.
So
some of it's intellectual property. And I will also say that, there's a few people that we've met and that are doing today said, well, why don't you just spell it out? Because it's what makes us dramatically different.
So I want to say, this is technology, right? Now look at the business advantage. It took us more than a year to develop this, and we received the Global Red Herring Award for innovation for inventing this. Now look at the business advantage. With this technology in place, you can place a freight train on your van in broad daylight. You can send a 20 gig image during business hours, and it will go anywhere in the world without impacting your business. So that's really the advantage. You are completely liberated from this whole, who wants to work at night to image machines? You can do it in the day using this. There was a question about critical patches. Critical patch comes, you need to deploy it during the day without impacting the business. This will do it automatically for you. There was another question.
So with the existing setup of the manager, and if you want to deploy it, do you have to change anything in your network equipment? This just gets installed?
Not at all. Not at all. It's completely self-configuring. There is no router change needed anywhere.
Go ahead.
So is this a protocol analyzer that has to sit on both ends of sending and receiving?
That's a good question. You're correct. And the way it works is, in the one-site system, the Adaptiva server only sends out the very first copy of content to a local client. All further transfers are entirely P2P. Right? So there are two clients, one-site clients involved in the transfer. One guy is the sender, the other is the receiver, which is exactly what's going on here. And that protocol actually does have two components, and there is communication that happens. They share and collate data as part of the protocol.
Okay, so follow on that question then. Your sender, and if the receiver is, say, an SCCM client,
I need to make sure this door does not slam.
So
either something.
Every client machine is going to have an Adaptiva agent installed.
Sorry. It's like every time the door slams and there's a guy out there that's reading a book and should be stopping the door from slamming. Sorry. It's like somebody's got to have a job here.
You're a colorful individual, my friend. So
Well, there's no change in the door this time.
So there is an agent that you install, right, the Adaptiva client on all the machines where you want to use this. Now, there is no reboot required, there's no configuration, nothing, there's no pop-ups, right? You install the agent, it self-configures, and installs whatever it needs to.
Can you use it to transfer data between your primary sites? Like I have primary sites in PAC-RIM, Americas, and Europe. So I want it to be able to transfer my content into my primary sites.
Absolutely. Absolutely, it will.
And then you can use it to transfer from the primary sites down to secondary sites.
Well, this will eliminate the need for secondary sites. Why do you need secondary sites now? Those.
No, they're there. I walked into them.
So, we work with this use case very often, and our recommended best practice is uninstall the software, uninstall the secondary site software from that machine, install a one-site client on it. We will utilize that machine as a content source. And there's a registry setting. It will become a preferred sender. It will fulfill that function without your having to manage a secondary site. Neil, thank you very much.
That's right. We're going to get to it. Why are you jumping ahead all the time?
Hey, because I've got 58 Pixie servers.
58 Pixie servers. All right. Awesome question. So, Neil, thank you very much. Neil will be here for the balance of this and then afterwards a little bit. Next, I'm going to introduce Howard Bliss. He's at Barclays. So he's got a little bit of an accent because they're based in the UK. We'll let Howard talk about his environment and then the virtual SAN, or the caching file system, which is another unique Adaptiva protocol that we've developed.
Hi, I'm Howard Bliss from Barclays. I work in the Windows engineering team, and I do look after application packaging and also the configuration manager environment within Barclays. So today I'm going to talk to you about the Adaptiva Infinite Cache. So most of you will be familiar with Configuration Manager Client. When you install it, typically it's going to give you a 5 gig cache by default. And that's if there's enough space free. You can go through, configure it by percentage. But this type of cache has got a bit of a disadvantage, or a number of disadvantages, in fact. The content is only proactively managed during the time of a deployment. So if the space is shy on that box, you're going to find that the SCCM client is going to discard stuff that it doesn't need to make way for the new content. What also happens is you might have, sorry, the cache is also consuming space that the system or the user may require at some point. So once that happens and you start hitting limits whereby you're out of space or you don't have enough content, you start getting into proactively manage or manually manage that content. So you're going to have to go in and use tools. You've got things like SCCM Client Center and things like that, which enable you to view the contents of the cache. But then you've got to actually understand which bits of content can I actually discard. Because as soon as you start discarding that content, then you get into the problems of actually having to recopy that content down at some point, potentially, to that client, and then you're starting to impact the network again. So what we have in Adaptiva is a bit of a novel solution to that problem. So if you imagine that you have an office and you've got 20 clients in there, each of those clients has got, let's say, 200 meg worth of free space on them. That's about 4 terabytes of storage just sitting there idle. So the Adaptiva client can make use of this, and we do this by using a filter driver that basically sits just above the NTFS file system. And what that actually allows us to do is to create effectively a virtual file store across that office. So we can take a look at that here on this system. So down in the right-hand side here, what we've got is a directory on the machine. Now, typically, this area is hidden. It's effectively a mount point. And in here, what we can see is a bunch of content. Now, there's a few other bits here, but this content that's in here, if we scroll down, is all compressed. So at the Adaptiva site server, what you actually see is the content that you've got for your package gets compressed, more so than SCCM. And then that content gets copied across the network. So that's like an additional saving over and above all of the that sort of complements the protocol, actually. So in addition, some of that content is also deltas. So deltas between different versions. So the Adaptiva client's only shipping deltas across the wire rather than the full content again. And it stays compressed all the way through to the client. So typically, if you're using like secondary sites and things like that, or DPs that are remote, you're pulling down the exploded content from Configuration Manager. So that means, you're copying 1 gig instead of like 500 meg, right? So there's an additional saving on top there. So the content sits in this cache, completely compressed, so that should this be required on another client in that site, it's already pre-compressed, can be shipped across without having to worry about fetching the content or recompressing it. So it sits here.
Use the mouse.
Oh, the mouse, okay. Now, in the top section here, what we've got is Space Sniffer. This just allows us to see the spread of files on the disk. And on the left-hand side of that, if you can read that, it says there's about 41.1 gig free. So what I can do is over here on the left-hand side, I've got a bunch of content. One of these is about 2.8 gig in size. And I've got a couple of other files, one of which is a PNG file. So to simulate sort of what happens under the covers, I can actually take this content, copy it across into the cache. Now, when I do this, what you'll notice is that the free space just doesn't change. So it's copying that file over. The free space is just there, unchanged. So to the user, it's imperceivable what's going on. Then the question sort of comes then, so what happens when the user wants space? So typically what happens here is, in this scenario, we've got 41 gigs worth of free space. The user's just going to start requesting storage for their Word doc or what have you. As and when they request that storage, the filter driver basically works out which bit of the free space the client's not using and offers that up, and the user consumes it. At some point, we're going to start overlapping or requiring more storage that's going to overwrite the content that we want. At that point, the client determines which is the most prevalent piece of content within that site, and it discards that, and it keeps working through that algorithm until there's enough free space. And the reason why it sort of does the most prevalent content on the site is so that we avoid ever having to replicate, or at least we limit the chance of ever having to re-replicate that content over the wire again. So it's a bunch of smarts that sort of optimize your whole network delivery. And I think that's about it.
Yeah. Thank you.
So a brief demo. Happily take any questions.
Here you go, Howard, over here.
Fire away.
How does this defragmentation, impact this process? Like, in other words, like if I run a defragmenter, this defragmenter, would that impact how this process works?
No, not at all. We don't change. So let me explain a little bit about the internals, how it works. So NTFS, when it needs to create a file, it will allocate clusters, and then those will be marked in the tables as used. And then it'll copy data to those clusters. We do something similar. We just don't allocate the clusters and mark them in use. We simply use free clusters and copy our data there. Now, so the cluster is actually free, but our data is sitting in white space. Now, what we do in addition is we insert ourselves into the path that allocates clusters. So when a user mode thread comes and says, I need 20 megs worth of clusters, we will give out those clusters that we are not using. Okay. Now, at some point, we're going to run out of those clusters, and then we'll have to give something we are using. And we use the algorithm that Howard described so that that machine will lose content, but the office as a whole, that location hasn't lost any content. Now, this is all technology and it's very fascinating. Look at the business side of this. We are giving you infinite caching. Once a piece of content gets sent to your branch office, it's not going anywhere. Consider an office with 20 machines, 100 gigs average free space. We are harvesting 2 terabytes of space that you're going to use for your cache. Not 1 byte is actually taken away from any user. So this is the second pillar of OneSite. Again, a revolutionary technology. We are the only ones in the world who have this technology.
Other questions for Howard? There you go.
So it's running in the kernel. It's the most it's ring 0 code, so it has all the privileges that Windows has.
So it's not going to collide, interfere.
No, it is completely integrated. So we develop these things in close cooperation with Microsoft. We are located 5 miles from their campus, and I worked there for many years, and we have great relationships, teams across the board.
So great relationships, but beyond that, certified and signed. So that's a great question. We hear it all the time. You had another one? Go ahead.
First question, I want to make sure I understand what you did down here. Copy files from one location to another.
Yeah, what I did was I copied one from the normal drive or system or disk that you would see normally as a user, and I copied it into the Adaptiva cache just by accessing it through the mount point on the system disk. So typically on the system disk, you'll see it in the root of the disk. It's hidden, but you can navigate to it. C::Adaptiva cache, for instance.
So the server or the location you copied it from is an FD. The server is a client sitting on the other.
No, I copied it from an actual C drive on the machine already, so it was just sat in a normal area.
Okay, and then so it goes over to this other location, which could be another SCCM client.
No, what I'm doing is giving you a view. On the right-hand side, I was just giving you a view into the cache. It's just a mount point, so it's a directory on the machine for all intents and purposes.
I may see the confusion. You publish something in Config Manager. You have no more distribution points or secondary sites. Where's it going? Howard was, in essence, publishing a 2.8 or 2.7 gigabyte file, and it hides in the caching file system. A hidden file system in that arena. He's representing it to you because if you go in and check your C drive and says, hey, I still got 41 gigs free, nothing's happening in the background.
I was just simulating what the client does when it gets the content and pushes it in into the cache.
Yeah, in the same machine?
Yeah. Just for test purposes, if I copied it, if down there in the left-hand panel, right, that was a network location, and I copied it into the cache, you'd see the same net result.
So I'll just add a couple of details there. So, it doesn't matter where the content came from, right? We are just, this demo is about the caching file system, right? So it is convenient during the demo to not copy it from the network. The file system, the caching file system, is mounted in the Adaptiva cache folder, right? So, which makes all the files stored in that file system look, behave, and function like normal NTFS files and folders. So you can create a folder here, you can copy files. The Adaptiva client software will copy files here, and so can you, right? It's a file system.
Okay, so what happens if you shut down that Adaptiva client? the machine, the physical machine.
The Adaptiva client will, as part of a shutdown procedure, shut down the driver as well. So the files will not, the free space will not be available anymore.
For this one, you got 17 questions left, don't you? I would suggest you come by. It's fundamentally different than a lot of you. This is the first time you've seen it. Those who haven't, you kind of get it already because we've gone through it. But it is how the business issue that we're solving here is the elimination of all that infrastructure. You don't have to care and feed it, replace it, buy it, put software on it, warranty, all that stuff. That's the business benefit. The technology, we're happy to go into it in some depth. Laurent, you had a question?
Todd, let's close on this. So I would invite you to our booth, and we can. So you're obviously curious, and I don't want to just monopolize everyone's time on this particular issue, but we'll disclose everything you want.
It's a yes, no question. At Vcash?
At Vcash works similar to the SCCM cache. So that consumes space that, or takes space away from the user. So this is completely different.
So it doesn't fall into this?
No. You'd get at V content potentially down there as compressed, but no.
Go ahead. Back in the back.
It sounds like there's a partnership with all the clients where they all have the driver, and they work out amongst the driver where the files will be located, and sometimes duplicate files so that when
Yes.
PC goes down, it can be accessed in another place. You had mentioned that files are transferred, compressed, and then decompressed. So as they're all working together, what is the footprint on the client as the driver works between the other clients to make that file available?
So I think we'll probably cover some of the way in which that interaction happens during the next bit, which is the daisy chaining. But yes, the clients are all, they use a rendezvous point to all talk to each other within that office, and the rendezvous point can help coordinate activities in that site. So that's where they go to find out what's the most prevalent piece of content on the site or within that office.
But the load on the client is what?
The load on the client in terms of network?
Yes.
Yeah, so in this case, the daisy chaining stuff that get covered in a minute probably give you a good insight. I don't want to steal his thunder.
But just add a couple of details. So every Adaptiva client does contain a tiny database. It's actually the database that is present on your Nokia cell phones. We've taken that database, embedded it into the client. So clients don't have to go ping and collect information over and over again. They already know who has what content. So it's a very well organized, centrally managed system. It's not chaotic. Clients have state. They know what's going on, and they will communicate if they don't have that state. But the common case is they will have that state, and they will not need to query each other repeatedly.
If it helps, I can give you a couple of quick high-level metrics as well for the sort of benefits that we saw. So 90 secondary sites, 260 odd DPs, and we're going to no secondary sites, and just over 50 DPs. And since we put it in, we've harvested about 2,000 gigabytes of saved bandwidth.
Shitload of stuff.
And that's just a couple of months.
That's the technical term. So if you want to talk to Howard about this, there are a lot of questions. I want to make sure that at least we breeze over and save some room at the end. So I don't want to, we just won't. There are 4 key architectural differences, and you will understand what, at least at a high level, what each of those 4 are before you leave here. But we get it because we do this all the time. There's lots of questions. Laurent was going to explain he's going to answer your question. He's not even a customer of ours. But it takes a little while to get it. And then I love the fact that Howard's saying, this is what we do. Howard doesn't work here. He's the customer. So I want to introduce Jason Snook. Jason has been involved in several of our implementations from the consulting side. He's now recently moved over to Flexera, fortunately a partner of ours as well. And Jason's going to talk about the peer-to-peer. And you'll hear us say true peer-to-peer content distribution. And we say true peer-to-peer content distribution for a reason. And we're going to show it to you, physical software. Go ahead, Jason.
All right, everybody. So everyone can hear me okay? There we go. So typical software distribution in SCCM, the client reaches out to a distribution point and pulls the content down. So if you have a site with, say, 10 clients and there's no distribution point there, you have 10 individual clients reaching out to a distribution point and pulling it over the WAN. That's usually affecting production environments, especially if you're just throttling bandwidth and you're saying, use 10% of the bandwidth. and you have a peak in the network, and it's going over and using that, and you're impacting production traffic. What the peer-to-peer distribution model will do is copy the content once over the WAN and then share amongst the clients within that local space. So that's what I'm going to show you here. So what we did is we distributed a package to our Sydney site, and there was 10 clients. And the package was just an MSI, it was Skype, and it was, I believe, 20 megs in size. So what we can look at is what would happen was we distribute the software out. The Adaptiva clients forms a chain. One gets elected to copy it across the WAN, and then all the others take a number. So they have number 2, number 3, number 4. The first client starts downloading the packets across the WAN. The moment that the first packet hits memory, not even written to the hard drive, that packet gets sent on down the chain to number 2, the number 3, the number 4. The benefit of that is if there's a break in the chain, it reforms that link and picks up where it left off. So you're not starting all over and extending the length or the time it takes to download that content. So what you can see here is kind of a demonstration of the chain. You can see that let me scroll this up so you can see from the download source, you can see that we pulled it once across the WAN from a different network, and then we passed it along. The clients formed the chain. You can see none of the IP addresses are repeated. That's the daisy chain working. And then over here, and what is really great, and what's great to show the network guys, what's great to show all your C levels is not only did we download it just once over the WAN, and we've also compressed it down to just under 18 megs. So we took that 20 meg file, we compressed it down to 18 megs, and we've only done it once. And then everything else is a LAN cost. It's all just distributed locally. So, any questions?
We'll show this to you live in the demonstration. One of the questions, if you got a really big subnet, what happens if one of those comes out? Single point of failure? Nope. Come and talk to us. It's absolutely untrue. One will go out, be picked up and leave the office, and as soon as it needs the client, it comes back in, plug it back into the subnet, they'll automatically shake hands, join at the end, deliver the content.
Yeah, it'll just keep going on and on and on.
And we'll show you that too in the live demonstration. You got a question here?
Yeah, in my environment, we run probably 70% laptops, and I would say 15% of those only connect VPN. How does this work?
Great. So what big deal? What's the problem? So why don't you come talk to be facetious. Yeah. Who are you with?
Armstrong World Industries.
Oh, that's right. The floor and ceiling guys. Yeah. Come over and talk to us. It's a great. He's with Armstrong. Go see Paul too. Paul's my competitor with 1E. And no, seriously. And Paul's from Seattle too. I like Paul. It's a big world, right? But that sucks. Go figure out a way to solve it. Somebody had a question up here.
But Todd, can I just give a quick answer on that question?
Richard?
No, I was going to ask, because here's, I see these 10 clients are all on the same subnet, right? So, on the same segment. So, the daisy chain is limited to the segment?
No.
It's
No.
not.
This is for I'm too close to that, sorry. For demonstrations, go ahead, Jason.
Yeah, so automatically you can have it just on the subnet, but if you have a location that has multiple subnets and you want them to be one location, you can absolutely form that as one location. You're not limited to just one subnet. Just a simple demo. So we limited it to 10 clients, and we just kept it on the same subnet to keep it simple.
Okay, so say I got 10 subnets in my network, right? So the first client that downloads it across the line VPN, right? Then that client then the daisy chain starts from that one client across the subnet?
So it's not that it downloads it and then it sends it on. It starts downloading it. It doesn't even write it to the disk yet. It hits memory, and it shoots it out to the next guy. And then the next guy shoots it out to the next guy, and so on and so forth.
On the other
on the other subnets as well. Yep.
Okay, Deepak, I know you're chomping. I'll give you just 2 or 3 minutes on it because there is a lot more. Richard picks up a good question. This is just one subnet. You can group Cargill. Neil has done some amazing stuff. Actually, Stu has with grouping subnets. Go ahead.
So this is a very good question. So, in these sort of group demos, we can only scratch the surface of the product. There's a lot of depth. There are some very sophisticated algorithms built in. Now, we detect chassis type automatically. We handle laptops differently. It's all built in. What will happen is, if there was a non-laptop machine available on that subnet, that machine would go across the WAN. The laptop would not go across the WAN. Now, we use a lot of parameters. We prefer desktop chassis over laptop chassis. We prefer server operating systems over workstation operating systems. We also look at system uptime. If a machine hasn't rebooted in 51 days, he's going across the WAN and getting content. You also have configuration options available where you can say, hey, I have a DC here, which is always there. You can mark it as a preferred adaptive client. It will always insert itself into the path and will perform the primary download across the WAN and always be at the head of the chain. So these are all behaviors built in, and there's a lot of, we can discuss it during, if you stop by the booth.
Great
But
question.
It's
So
very
anybody-
comprehensively handled in the product.
Anybody in here with in big finance? Right? And you talk about clients. Anybody here have a group that has a trading floor involved in their organization? Right? Those guys, I think it was Don and Gerard, or maybe it was Howard. I said, you just, either Barclays or CIBC or maybe HSBC or whatever. I said, you just put a little bubble over those guys and exclude them. And don't fight the battle with internal organization because like Deepak was saying, servers over chassis over laptops, you can do the same with groups. So just exclude them and make your life easier, and then eventually they'll come wanting for the solution.
What happens if you lose the zero client? We'll call them. Does somebody else get elected at that point?
Great question. Wouldn't it be awesome if that was the case? Come on over and talk to me. The answer is yes. But the answer is yes. However, I will go a step further, is come and see one of our technical guys over there, anybody, and say, I want you to turn that one off right now in the live demo.
I say think about the matrix with the agents.
Yeah, think about the matrix, yeah. And go like this. But bring those use cases and then make them do it live, because they love to do it. Neil.
Yeah, I just wanted to add something that we found surprising when we were testing this in the lab. What we did is we created an OSD deployment, and we have, inside of our lab, we had 2 local network segments, and then we had another network segment that was across a WAN simulator. And we brought it down to like a 512K bandwidth. And we did the OSD deployment, and we saw that, we started to see the chain form and all the content happening on the local, and then we also watched it through the WAN simulator, and we saw it slowly trickling down. So that was no surprise. And then we went home. Happens sometimes. Came back the next day. Of course, all the local content was there. It was shared across all of the clients. We saw it in the cache. We still saw it going across the WAN simulator. We thought, well, that was cool. Still going to take a while. What would happen if we took one of the PCs that had the content already and just walked it over to the other table and plugged it in on the other side of the WAN simulator? And we were watching the network. What happened was, within a few seconds, it stopped doing the transfer across the WAN simulator, connected to the client, and transmitted the rest of the client from the local
That's all I get? That's pretty cool? How about freaking awesome? Or are you me?
The first time
I forgot about that one. Why didn't you start with that one?
The first time we saw this, we're just like, well, we screwed up the WAN simulator. There's something wrong here. But no, it actually recognized as it participated into, now it's part of that chain on that network segment. It saw that I don't have to go across the wide area network anymore. There's someone in my house that has it already.
Yeah,
I'm going to
that's
stop
awesome.
the transmission and take it and fan it out.
You can do, sure, whatever that was. Can you group servers in that? I don't, come and talk to us.
So I thought I just share that because I wasn't expecting that behavior at all.
Okay, if you got any more cool things like that, let me know. Jason, thank you very much. Introduce James Bannon, who is an MVP for Config Manager, so clearly he knows this stuff pretty well. He's in Australasia, which I think is ANZ and Singapore and stuff like that, and he's a chief solutions architect. I don't know how far you've gone, Bob, from a geography standpoint. Pick it? Huh? Yeah. So Bob and his organization has been a very strong reseller of ours. They're on a different time zone in Australia, so we're in Seattle. They've been awesome.
We're in a different day.
They're on a different day as well.
We are the future, Todd. What are you?
You are the future. And you've got great wine. So we're going to talk about peer-to-peer Pixie for OSD. And then we'll leave a couple minutes for questions. And then make sure that it may take a couple seconds on the way out of here, but we're giving away this Harley, or as we talked about, $5,000, I think, dollars in cash. You stayed to the end. Get scanned. You listen to us and get scanned again. And I will tell you, we're not going to call you and say, hey, do you want to? You'll figure it out. Like Armstrong's got some big enough problems. I bet he's going to call me. Go ahead, James.
All right, cheers, Todd.
Yes.
And thanks for everyone turning up this afternoon to take a look at this. So enterprise class OSD is obviously one of the main things that we want to be able to achieve with Configuration Manager. Now, what defines enterprise standard OSD? Now, it's really the ability for us anywhere, anytime, to get a machine, F12, Pixie boot, image drops down. Okay, that's really the end goal. We want it completely zero touch, ready to go, minimal maintenance, minimal overhead. We don't want to go with boot media or whatever. However, how many of you have got sites where that just is not practicable? You don't, so you need a DP, you need a Pixie point, you need WDS, you need to get the content out there. And maybe you've got a site that is, one man and his dog, and they've got a laptop each. You're not going to stick a site server out there. Okay, so what often tends to be the case, and we see this a lot with our customers as well, is that those sites pretty much just get left. It's understood that they're never going to get the type of server infrastructure that they're going to need, and that the SCCM guys are pretty much just going to have to handle that. Well, what we would prefer to do instead is treat every single site as enterprise standard. But one of the first things that we're going to need to be able to do is enable that Pixie. Now, what we can do with Adaptiva, and this is one of the secret black magic secret source things, is enable every single Adaptiva agent throughout your environment as a Pixie server. That will let you Pixie boot any workstation from any other workstation that has been enabled as a Pixie point on that same subnet. Okay? Enabling this is one of the easiest things in the world. If we take a look at the Adaptiva workbench here, it's simply a case of tick, enable P2P Pixie. We're done. We're going to drop down and say, well, all right, we need some boot files that are going to be relevant. We'll either get them from the wake or we'll get them from ADK if we're talking about SCCM 2012 Service Pack 1. Do we need any particular credentials? No, we don't. Which collection of Adaptiva agents do we want to be enabled for P2P? In this case, we want all of them. We can exclude some of them. If there are some that we never want to serve Pixie, we can exclude them. And if we want to do any sort of nice advanced stuff like SCCM task sequence variables, we can do that too. And of course, that critical one there, enable unknown computer support, so that when a Pixie request is received from one workstation to the Adaptiva agent, it understands, is this known, is this unknown, and it will handle it exactly the same way that a Pixie-enabled DP within SCCM will. As soon as this is enabled, and it's ready to go, it's going to jump in and grab the boot files from the wake or the ADK. It's around about 0.5 meg package, and it's going to instantly distribute that to every Adaptiva agent using the adaptive protocol, using the Adaptiva cache, using the daisy chain transfer. So it can be done during production hours. It's quick, it's silent, it's under the hood, it's done. Now, let's see that in action. I've got a nice little workstation here, ready to go. There's another workstation on the same virtual network, which has the Adaptiva agent installed. It's already been enabled for peer-to-peer. Fire that up. No pressure.
It's like watching paint dry to me. But I guess if this is your life, it's good. When we first showed this to, I think it was to Howard, to Barclays, we had scheduled a 2-hour meeting, and we were going to, go through this whole thing. And like, the guy like James was doing the demo. He said, okay, click that button, and you pick the collection, you hit go. And Howard said, well, that was quick. I said, well, we could add some more clicks and, dials and radio things that you have to do. But it really is that rapid to enable your entire organization to do Pixie Boot.
Absolutely. As we can see in the console, the Adaptiva agent is completely aware and has already reported back to the server that there's a Pixie request which has actually occurred. Where's it come from? What's the machine? Now, obviously, as we all know, everyone here, config manager administrators, we work with it. Yeah, pretty much. So we all know that under the hood, there's obviously a lot more to it than that. If a machine gets a Pixie request, that must mean that there is a task sequence which has been advertised. So how do we bring Adaptiva into the mix and ensure that it is handling everything we need? Well, this is where we get to something. I was going to say something very cool, but I think it's actually something else that's very cool.
The Vim is downloading now.
Yep. It's also just worth pointing out. It's grabbing the boot Wim, and it's grabbing that. That's one of the workstation IPs. So it's not coming off a server. Just dropping down, ready to go. It's almost underwhelming when you watch it in action because that's what I expect. Yeah, but that's coming off a workstation, not a server. And if that workstation was not available, it would choose another one. Easy. What we're going to take a look at is content push. As part of OSD, of course, one of the critical things which occurs when a task sequence runs is that it jumps out, looks at the task sequence, looks at all of the dependent packages, package IDs, which are referenced, and checks the content source and makes sure that it's there. Otherwise, it isn't going to run, right? So how do we make sure that all of the content for this OSD task sequence is already pre-deployed to the Adaptiva agents and that it's ready in the cache and ready to go? So we do this using content push. I'm going to create a new one. Here we go. Now I'll jump out into content list. So what we can do is simply drag and drop a configuration manager object. Now it's a little bit small to see, but this is a configuration manager task sequence which we're interested in. So we're going to deploy Win7, drag and drop, in it goes. It automatically takes a look at all of the reference packages. Say, right, so these are the ones that I need to deploy. Excellent. It was basically as simple as that. However, in general, there's some fun stuff. We're going to tick publish unpacked content so that we can enable that for OSD. It's simply a prerequisite. There's this wonderful little checkbox here called auto push. I'm going to come back to that so that I can stress it and let the awesomeness sort of flow across you. But we want to work out, so when do we want this, when do we want all the required packages to be pushed? Well, actually, we've got schedule. I want that immediately. Thank you very much. And which collections do I want this done to? I want it to my managed workstations. There. So drag, drop, drag, drop, drag, drop. Nice and easy. What does auto-publish content changes mean? If you were to make a change to one of the dependent packages in that task sequence, say you update a driver pack, or there was a change to the master WIM, Adaptiva is going to actively monitor the content within this content push policy and say, hey, there's been a change. There's been a change to the WIM. It's now 50 meg larger. There's some extra, the driver pack suddenly got larger. Okay, it's a change. Flag that as a change that's needed across whichever Adaptiva agents I'm targeting, and get that automatically pushed out. Now that occurs at the block level, so it's only replicating the changes. If you've got a 20 gig WIM and you've added in one more package to that and it's now 20.1, it's not going to push out an entire 20.1 gig WIM. It's only going to push out the changes which it needs. But it's going to constantly monitor that, make sure that content is always ready, always fresh, so that when you're doing OSD, everything is exactly right in the way it ought to be. I think that's pretty awesome. However, obviously, all of this comes back to where we do our work, which is Config Manager. So what do we actually need to do as Config Manager administrators to enable all of this excellence? Answer is not very much. It's pretty minimal. This is the task sequence which I'm going to deploy. If I take a look at the properties, go into Advanced, you see it's using a custom boot image. That is effectively the same as your stock standard native SCCM image. The only difference being it's got the Adaptiva, the one-site downloader tool, which has been incorporated into it so that it can make use of it during WinPE.
Can you just click on the OK?
And if I take a look at the task sequence itself, all I've had to do is add in a task sequence variable, which is it's a native one within SCCM 2012 Service Pack 1 to enable, it's the alternate content location flag to tell it where to grab the one-site downloader from. And that's basically it. After that, when the task sequence is running, it's going to know exactly where its package content is. It's going to know how to grab it, and all the rest is handled by Adaptiva. So one of the things I particularly love about this is how we can now enable all of our little satellite sites on very low bandwidth. We can give them the same enterprise standard functionality when it comes to OSD that we can at our main sites. It's also worth mentioning that in enabling peer-to-peer Pixie and allowing it to work, there's nothing that you need to do from a networking point of view to enable this. So you don't need DHCP options, you don't need router changes, IP helper addresses, nothing along those lines. You simply turn it on and it works. It's ready to go. So I hope that gives you a bit of an indication of just how easy it is, and but more importantly than that, how powerful it is. So any questions?
Questions for
Yes,
James?
sir.
Okay, so when the Pixie initiates, if the client that's serving up that Pixie session, that initiation, what happens if that client was to shut down during that initial delivery process?
If the client were to shut down during, so it responds to the request and then gets turned off. Good one. Deepak?
That's a very good question, actually.
Try it. Just try it.
So, you've seen, I'm just blown away every time I watch this demo, and I've watched it a lot.
Yeah, because you built it.
So, when you look at the Pixie protocol, it is one of the more refined protocols that came out of Intel. And very few products actually leverage the entire capability set of this protocol. So the protocol does not specify that the same machine should be the Pixie server and the TFTP server. This is just an implementation that has become tradition in the industry, and we don't do that. My cell phone can serve Pixie's 3 packets. So any machine which is, and we have a set of criteria, it will become the Pixie server and may or may not have content, the boot image. But it will find, when the Pixie request comes, it will find a machine which is currently online, and that will provide the TFTP server. Now, remember, when you enable, as James was showing you, when you enable P2P Pixie, you're not installing anything, you're simply enabling all those clients to become Pixie servers and TFTP servers. However, they haven't actually become that. They will become that on demand as needed. So the Pixie server will find a currently online machine to become the TFTP server. Now, during the download, if it shuts down, Pixie has no recovery mechanism built in. At that point, it will have to be restarted.
Physics, right? One more question. Yeah.
So, what about state backup for user profile?
State backup. Wouldn't that
That's
be
an
great?
excellent one. It's an excellent one. It has been a stick. I still feel the pain from it. We do that. We do that. It is just not well known that we do that. And we can show you, if you come to the booth, how we do it. So essentially, we have the caching file
It's like
system.
a plant.
We have a caching file system, and we do create a virtual SAN, and we have shown you its capabilities. We use the same technology as kind of like a RAID system. So you can back up your USMT data in its entirety.
You got that big virtual SAN now. What else could we do with that?
To that store, and you can also specify how many copies you want kept. 1, 2, 4, 5, whatever. Right? The virtual SAN will perform the replication for you. If you choose to, it will perform it in the background, or it will make your task sequence wait until it is complete. And then once the operating system is deployed, you can pull it back.
Good
It's all
question,
built
Tom.
in.
I
There's
said
really
one
not
more
much to do.
question. Tom's was the last question. Kidding. Go ahead.
In the virtual SAN, can you leverage both desktops, laptops, and servers? If there's some servers that you want to include as part of it?
Absolutely, yeah.
Yep. All of it. Grab it, hoard it all together, and use it. Great questions. So, go ahead. I'm going to get you out of here on time. It was like 2 minutes. Go ahead.
Not familiar with the product, but
Why not?
He was using another console to start all this. Is that there's no way to start this from the normal SEC console?
Great question, and the business guy's going to take it. You saw a separate console that you never have to use. If you don't want to do some of his, you've heard James say, here's kind of the really cool stuff, and now here's where the awe is going to come in. If you want to take that to that different level of unique, I'm going to take the trader floor guys off, those type of things, you never need to, in fact, you never need to use that workbench. You only need to use it the first time when you set it up, and if you want us to do it, we'll use it for you. So no separate console. Don't let this literal crap of, you got to learn 2 different things wave over you, and come and see it, because you absolutely do not. If you want to accomplish business goals, you can look for, how do I want to do it?
So Todd, may I offer
It's
an
really-
addendum to that answer?
Without mentioning any competitive names, go.
So guys, I'm going to show you something here.
But you're out of time. So as Deepak loads this up to spend a couple minutes, if you want to try this stuff, call me. Send us an email, whatever. We'll give you the bits. You can download it, CM7, CM12, both.
I'm opening a report here.
Don't care. And then the other thing is, from a services standpoint, we'll do it all remotely, or we'll come out and see you. Okay. If you have an existing technology and you have all that stuff, that data out there, we've got a migration tool that allows you to move it over to our stuff, should you want to do that. Okay.
So I'm going to show you the SCCM console, which I'm sure you've seen before, but look at it this way. How many consoles do you see? 3? There's no one SCCM console. This is SSRS. It's an optical illusion. Now watch me juggle the second separate console. It's hard. Look at that. Now look at that. What do you find easier? It's as simple as that. Now why do people love our console? Let me show you that. You want to add another schedule? Drag, drop. This UI was designed very carefully. It was designed for power users. You know, I was one of the designers of SCCM, you know, and I love this product. I will tell you, I have seen so many cases. This is a loaded gun pointed at your head, not anyone else's. The wizard UI is for children.
With that, all seriousness, if you'd like to, we'll be around tonight, we'll be around tomorrow. We'd love to talk to you, or you contact us or not. But the thing that you will get from us is a couple things. Hopefully you'll have fun when you engage with us. You will get straight talk. If the answer is no, the answer is no. I mean, if it's pixie booting and you turn it off, we can't, you got to start again. Not, oh, we were working on that, because we're not. So hopefully you've enjoyed this. I appreciate Neil and James and Jason and Howard for taking time out and presenting what they've done with our technology, and now you know who they are, and they're happy to give you the real scoop. So thank you very much for your time.
So guys, there's one thing I want to say. So the demo is over, and you're free to leave. There are some other cool things that we have not shown as part of the demo. In case there are a few people interested in seeing our business process integration layer, I'm happy to show you some workflow stuff that